In part 4 of section 3, we're going to be looking at the concept of increasing and decreasing behavior. So we already know how to describe domain and range of a function. We know how to find particular function values. We know how to find the intercepts and state them as ordered pair. But you will also find that many of your graphs will have this increasing and decreasing behavior throughout the curve. So it's important that we know how to be able to describe that behavior. So here in this example 3.5, it starts by saying let A, B, C, and D be real numbers. Now I don't know exactly what the value of those real numbers are. However, when you look at the horizontal axis on this graph, you will be able to see that B is going to be larger than A, C is going to be larger than both B and A, and then D is supposed to be larger than C, B, and A as well. So although I don't know the exact values, I do know the relationship between A, B, C, and D. And then it says to state the intervals of increasing and decreasing of f, where f is defined as having a domain from A to D, which is very reasonable. If I start at this point and I trace it down to the x-axis, there's A, and then I follow it on around. There's a value of B, follow this around, that has an x value of C, and then finally at the end I get to an x value of D, and then I would have, of course, everything in between. So the domain is certainly from A to D, even though we don't know the exact value of those. So what we're being tasked with here is not to state the domain, that's already given to us, but we need to describe where this graph is increasing and decreasing. So let me go back and clear this out a bit so we have some space, some clean space here. And I want to outline what I think that you as a student will intuitively believe is increasing. If I start here at A and I go all the way until I get to this top point, I think you would probably call that increasing. And so if I'm looking on the horizontal axis, I would say that's from A to B. That's where I have an increasing behavior. And let me get a different color, and let me start at the top, and let me start going down as I move to the right, and then I would stop here at C, and I think that we would agree that this is a decreasing behavior. And so starting from B going to C, I would have then a decreasing behavior. And then it starts again with increasing. Starting at C, if I continue up to this highest point, then I would have another increasing behavior from C to D. So the way that we end up writing this is based off of the definition 3.2 that's here below. So we're going to look at the definition while we're working through example 3.5. It says here for number 1, f is increasing on an open interval. So anytime you want to describe where something is increasing or decreasing, you are supposed to be using open intervals, because it says the same thing here for decreasing. Use open intervals. So I'm going to write INC as an abbreviation for increasing, and the first increasing that we saw was from A to B. So notice that I'm not using square brackets, I'm using open brackets, or open parentheses I should say. And that was not the only interval that we saw increasing. We also saw increasing occur from C to D. And then decreasing, we saw one interval of behavior like that, and that would be here from B to C. Now, I rarely have students argue with me about this result. Now, the only time I have students that might potentially argue with me about this is if they feel like we shouldn't be reading the graph from left to right. And when you think about reading English, you always start at the top left and work your way to the right. But not every language in the world is read that way. There are languages that start in the top right and work their way to the left. So in those countries where they speak those languages, would you be reading your graph from right to left? And it's a legitimate question. And this is something that mathematicians as a society had to decide, okay, what is the convention? So that way, no matter where you are in the world, we will all read the graph the exact same way. Now, fortunately for us, the convention is going to be to read your graph from left to right. But mathematically, mathematicians had to say that. So let's go into this definition just a little bit further, and I'm going to show you where that language appears in the definition. So back at the beginning of 1, it says f is increasing on an open interval I if, so this is the condition that we want to see happen. But that can only happen whenever this occurs. And this statement that I have boxed in right here, this is the way that the mathematician says, read the graph from left to right. So I'm going to illustrate the way that this definition is applied to our example 3.5. So we agree that a to b is an increasing interval. So according to this definition, I should be able to pick two places, two x values in that interval. So I'm going to pick this x value and this x value right here. So what we're about to apply from the definition should work for any 2 points inside of this interval. And the convention says that x1 has to be less than x2. That's what forces us to read this from left to right. So I have to call this one x1 and I have to call this one x2. I can't reverse that. Definition says I can't. And then watch what I do with x1 and x2. I'm going to take x1 and I'm going to carry it up to the curve. And I'm going to mark a point, and then I'll go over horizontally to the vertical axis, and that's going to show me the location of f of x1. And then I can do the same thing with x2. I'll take x2 and I'll carry it up to the curve, and then I'll carry it horizontally over to the vertical axis, and that's going to show me the location of f of x2. And I'm supposed to then be comparing f of x1 to f of x2. And the condition that I'm supposed to have says that f of x1 is supposed to be less than f of x2. And certainly, it seems pretty clear that this value is going to be less than this value because it's lower on the vertical axis, and that would be a correct way to look at it. So if you have that condition, then that means you must be looking at a increasing interval. Now, as I said earlier, intuitively, students typically don't have a problem with this. But from a mathematics perspective, we have to be very rigorous in the way that we define these concepts, so that way they don't get confused around the world. So you typically will not have to use this definition to really apply the increasing decreasing concept, but it is good that you understand the definition that's behind it in case you do find yourself in a situation where you're not sure if you're looking at an increasing or decreasing interval. This will help you to be able to make that distinction. And then very quickly, looking at part 2 of this definition, if you want to be talking about a decreasing interval, notice that you have the same statement that says whenever x1 is less than x2 in I. So you still have to read the graph from left to right, but you'll notice that the inequality has switched to now be greater than. And that's what makes this become a decreasing interval versus increasing.